All right, welcome back. This is section 12.2, also known as the last section of the course. Wow. This is test for independence and homogeneity of proportions. It's also another chi-square type thing. We're going to be talking about test for independence. Next slide. And the test for independence is talking about contingency tables and marginal frequency distributions and things. Remember the number of pets in urban, suburban, and rural communities way back in the first part of the semester, and we talked about, does it seem strange that people that live in the country seem to have 2 or more pets and people who live in the city don't? And we talked about how that made sense, right? Well, that's what this test right here is going to talk about, is when you have a table full of values, is there necessarily a correlation, a dependence between those things, or are they independent of one another? And the chi-square test for independence is used to determine that. Next slide. I like having you here. Thank you. So the null hypothesis is the variables are independent, or they are not associated. The alternative is the variables are dependent or are associated. So that's what the null hypothesis and alternative hypotheses always are. So that's good to keep in mind. I went through a couple of homework questions where one asked using the verbiage independent, another one used the verbiage of associated. So get to know both. Remember that independent means not associated. Next slide. So I think I'm going to start, in theory, how does it work? Well, the idea behind the test is to look at the counts that were observed and compare them to what you would expect if all the row and column variables were truly independent. And if there is a significant difference between them, then naturally the test fails. Next slide. Remember the multiplication rule for probability. For this and this, if the two events are independent, the probability of the intersection of those two circles, the football shape, if you have an and, you find the area of that, you find the probability of that by multiplying the two together. And you may recall from last year and even this year, if the size is too big, then there is a dependence, a positive dependence. Sometimes the overlap is too small or non-existent, mutually exclusive. That would be a negative dependence. But in either case, there either is a dependence, positive or negative, or there's an independence, a just right size amount. And knowing that the probability of E and F, if they are independent, is simply multiplying them together, we can use that to figure out what the probability, what the probabilities and what the expected counts would be for this contingency table. I'm going to jump to an example pretty quickly. I think go ahead and go to the next one. This is a great example. It's just a fun example to work through. In a recent poll, 883 men and 893 women were asked, if you could have only one of the following, which would you pick? Would you pick money, health, or love? And before you go on to the next slide, it's an interesting thing. I'd love to do a little poll right now with you, but I wouldn't see your hands being raised. Would you want money? Would you want health? Would you want love? And the men and women answered these questions, then you can see the results on the next slide. And we're going to test this at a 5%, which is the typical thing. And the question we're asking are, well, I guess first of all, we're going to find out what the expected values are. And this is in theory. StatCrunch is going to do all this work for us. So grit your teeth and hang on over the next couple of slides to see how this works. But I left it in here because I found it kind of a fascinating idea. Next slide. Here are the results. If 82 men, 46 women chose money, 446 to 574 chose health, 355 or 273. So much for women being the hopeless romantic. That just doesn't seem to be the case, and maybe men just really are greedy. And and maybe women are just hoping that they will outlive their man to find, I don't know. There's all kinds of different things that you can interpret. But the question then is this: if gender was independent, then would we expect, what would we expect these to be? And furthermore, are these close enough to being the same to pass the test? To go to the next slide. So what we're going to do is we're going to create a marginal frequency table, so that you'll recall that we just add these three together that find that of the men that were divided into those three categories, well, there were 883 of them, right? And there were 893 women for a total of 1776, and then love, health, and money. Now, keep this in mind. This probably makes sense to you. Let's just say, is it going?
I think it stopped.
Oh, did it stop?
Oh, no, it didn't.
No, it's still going. It's in low. It's not low power mode yet. Whew. Okay. I got a phone call the other day. Did I tell you about that? And it cut off one of my videos. It was so crazy. Hopefully no one calls me now. No one ever calls me. So the question then, here's the thing. If these two were exactly the same, if there were the exact same number of men as women, if your choice between money, health, and love were independent of gender, then these would be exactly the same. And these would be exactly the same, and these would be exactly the same. I'm not saying that the totals would be the same. There are preferences. There are clearly more people that prefer health than anything else. But within the two categories of men and women, if they were independent, then these would be the same if these were the same. Now, these are not the same, are they? So they're going to be tweaked a little bit. Next slide. So what we find out is the whole idea of that multiplication rule. So we find StatCrunch, right? StatCrunch finds it. But we would find each expected count by what is the probability that a person in this survey is a man? That is 883 over 1776. That's 0.497. What's the probability that a person in the survey chose money? Well, there were 128 out of 1776 that chose money. So the probability, if they were independent, of being a man that preferred money would be by multiplying these two things together to get 0.036. Well, then the expected count is just that percentage, 0.036, times 1776 to give 63.64. Next slide. And we see we do that for all of them, and we find, see how these are very close to being the same all the way down through. Slightly more women than men in each of them because there were more women surveyed than men, right? So we don't do any of these by hand. That's just the theory on how it goes through. Next slide. So the question then is, does your preference depend on gender? Does your preference of money, health, or love depend on gender, or is your answer independent of gender? So how do we go through this? Next slide. So we got our samples. How many tests? We got 7 tests. Chapter 10, Chapter 11, Chapter 12. This is a right tail test. Not greater than. It's going to be a, next slide. It's going to be a not equal. They are, I guess, not really not equal. They are either independent or they are not independent. They are dependent variables. Next slide. She's getting bored. Are you guys getting bored? She's standing on the chair. Don't stand on the chair.
It's low power.
It's okay.
It's gonna.
I know it's gonna stop. It's still going. You keep distracting me. I'm gonna run out of battery. Level of significance still 5%. Next slide. Critical values. Now this is an important thing that the homework and quiz may show up. How do you compute degrees of freedom for this? Well, if you recall, there were 2 row variables and there were 3 column variables. And the way to compute degrees of freedom is to take row variables minus 1 times column variables minus 1. 2 minus 1 times 3 minus 1, that's 1 times 2, so 2. So the degrees of freedom is 2. Go to your chi-square table and you can find that a 0.05 chi-square critical value is going to be 5.991. Next slide. StatCrunch. You may have to type this in. Again, take some time to type these things in well. I made this column header as gender money, health, and love. And the more you label this, the easier it is when you go through to create the test. And how do you find the test for this one? This one's hidden. So next slide, I try to make it easy for you. You're going to click on Stat up there. You're going to find tables, contingency tables with summary. So when you find that, when you click summary, next slide, you're going to get this option box. And there are lots of different things you're going to want to select in this. You do have 4 columns, but you only have 3 column variables of meaning, and that is the money, health, and love. So you'll select all 3 of those. You can click and drag. You can click the first one, hold Control, the second one, and the third one. First one, Shift, and the third one. And then the row labels is not optional. You need to click this one as, well, what labels are? That's the gender. So it knows that you're comparing those 3 with these 2. Go down and make sure you click expected count. That's what's going to create the expected counts for you. You don't want to do it. But if you don't click this, it's not going to display it for you. So make sure you see expected count, and then make sure, which it should be, the chi-square test for independence is selected. Next slide. And when you do that, you're going to see this, again, along with the expected counts right in there. You've got the marginal stuff that you probably won't need, but that should match what we did earlier. And you can, of course, see the degrees of freedom is 2, the test statistic, and the probability, which is extremely low, 0.0001. Next slide, and that is our summary. So what we can see, very small probability, right? Next slide. Next is outside, so reject. Next slide. There is statistically significant evidence. Next slide. What is our conclusion? There is sufficient evidence to suggest the choices you want in life are dependent upon your gender. Duh. Right? We probably would have figured that, right? And you could infer anything you want from that, but that is the case for that one. Short homework assignments this week. 6 questions, I think, on the first one, 5 on the second one. So enjoy that. I don't know how many questions are on the quiz. Usually it's 10, but I think even this one might be lower. I didn't look at the quiz. So enjoy that. The next thing I had to do for you is to create a exam review for you. I want to do that for you, and I think based on my discussion board, I think you chose, I don't remember what you chose, if you wanted a homework assignment or a test type thing. I think you wanted the homework assignment. But I'll look and make sure that I do the right thing for you. This has just been a fabulous run, first half with you in person, second half not as cool, but still I hope these videos worked well for you. Thanks for being here today, and email me with questions, and we'll see you.